Welcome to the myprojectbazaar.com. This is a project titled Trustworthiness Management in the Social Internet of Things. This is the abstract of our project. The main objective of this project is the Internet of Things. Here also we are going to transmit the information from the Internet server to the user. During this transmission, we are going to evaluate the trust value. Based on the trust value only, the user can able to receive the services from the Internet. IOF is dominated by a huge content-oriented traffic. Millions of persons can interact in the network. So heterogeneous communication occurs. In the heterogeneous communication only, we can able to receive number of services from the Internet. This will lead to the traffic in the network, and the problem of trustworthiness management occurs in the social IoT, where the objects are autonomously establish social relationships with each other objects. Without the effective trustworthiness management, attacks and malfunctions in the IoT will overweigh any of its benefits. The main problem is that how the information provided by the members of the social Internet of Things has to be processed. On the basis of this processing, we built a reliable system which is based on the behavior of objects. The main objective of our proposed work is to understand how the information provided by the other users is processed, then to manage the trustworthiness among the social Internet of Things, and to identify the malicious node based on the trust value evaluated during the information transaction in the network. This is a DFT of our process. First, we load the front network data. Then after that, we load the check-ins data also. The check-ins data contains the information when the friends enter into the network. After that, showing the results. Then we construct the model for using this two information. Based on this, we are going to combine two type of model. One is a subjective model construction and another one is a objective model construction. Subjective model construction is a theoretical analysis alone. Objective model construction is a practical implementation of the transaction of information in the network. In this, first we are going to identify the transaction between what are the transactions takes place. After that, the construction of the distributed hash table. The hash table contains the source information, destination information, what transaction takes place, etc. Afterwards, the feedback construction takes place. Based on the transaction, the user should give the feedback value in terms of 0.5, etc. After that, we are going to assign the transaction factor for each and every transaction. Then the assignment of transaction factor. If the particular transaction is an important one means, then the assigned transaction factor as a 1. Otherwise, if it is a irrelevant, it is not a serious issue at the time means, we assign a transaction factor as a 0. Finally, based on the transaction factor only, we evaluate the trust behavior. Based on the trust behavior, whether the particular node is a malicious node or not, we perform that identification process based on the trust value evaluated. Let us see the demo of our process. Turn to the NetBeans. Trustworthiness is our project title. In that, first run the load data.java. So our project title, Trustworthiness Management Social Friend Network Communication. Load the edges dataset. Successfully load into the database. Check-in dataset. Loaded into successfully. View the friend network information. Edges information viewed successfully. Check-in time information. These are all the checking time. These are all the node. These are the time which when the particular node enter into the network successfully. Distinct nodes in the network. Totally, we have 20 distinct nodes in our network. Number of transaction of nodes identified successfully. Total number of nodes in the network is 21. After that, we are going to run the This is a DHT table process. After that, we run the identify.java. It identifies the path. First of all, listing nodes in the network. After that, number of communications for each node in the network. These are all the count of the number of communications. For example, 2099 is the number of communications for the node 1. That is, node 1 is communicated to the other nodes 2099 times. Likewise, 1210 is the number of communications of the second node. Likewise, it shows for the 20 nodes. Then distributed hash table is generated successfully. This is a distributed hash table. The hash table contains the key of the source node and the key of the destination node. It contains node ID, source hash key and destination hash key. This is a source node 1. P2PN, it is a general representation, and 1 is a node ID. And then likewise P2PN is a general representation node 2. Likewise 1 is communicated to 2. Likewise 1 is communicated to 3, etc. up to, it shows the overall details up to 21th node is communicated to 18. 13th node is communicated to 14. 14th node is communicated to again 1. Then we are going to evaluate the weight factor calculation. It shows all the path details. This 20 nodes have the individual path. After that, first path 0 to 20, it have a path along a 0 to 1 to 0, 0 to 2, then 20. It is a self path. It is a different path. After that, these are the path of the all the nodes. First, it shows for the 0 to 20 and 1. Destination node is at 20, so it shows the path for all the nodes. Then service providing process takes place. Here we define the number of services. So the placement services: exam, entertainment, birthday, bank, food, password, ice cream, medicines, movies, etc. Enter the source key in the form. So we should enter the source node in the form of P2P for security purpose. 2PN1. Enter the destination key. 2. If you want to know the previous stress value, means click yes. This is a previous stress value from our source node and the destination node. Based on this destination only, based on this stress value only, the user should decide whether we can transfer our data from this node and to this destination. Then these are all the path. We just select the path, one of the path for our data transmission. Then select the service. So if the one is nothing but the transaction factor, because the service is a placement, so it is a important service. So here we assign the weight factor as a 1. Now we should give the feedback for the particular service, whether the positive feedback or a negative. The positive feedback means it should be greater than or equal to 0.5. Negative feedback means it should less than 0.5. So just enter 0.6. So these are the previous transactions. The centrality value, source key, source node, destination key, destination node. This is a path of transmission. This is a service, weight factor, feedback, trustworthiness value. These are all the then Then if you want service providing and if you want to continue means you just process. This is a comparison evaluation of our process. High trust value for the existing system for this transaction, then high trust value for the proposed system for this particular transaction. Thank you.